Welcome, everyone. We'll be started in just a couple of seconds as we have more people joining the room. All right. Hello and welcome to the 2023 Better Buildings Summer Webinar Series. We are dedicated to bringing you the latest actionable insights from leading industry experts. And this annual series is a chance to explore the topics, technologies, and trends that affect your organization, as well as efforts to accelerate, decarbonize, and energy efficiency adoption. Next slide. You are in the right place if today you are here to hear about the top 5 things you need to know about heat pumps. We are really fortunate today to be joined by multiple speakers who are each going to share with you one of the top 5 things they'd like you to know about heat pumps. Before we get into that, we do, of course, have a couple of housekeeping items. The first is that today's webinar is being recorded. So that means it's going to be archived in the Better Building Solutions Center, and we'll send that out to all attendees when it's available. And also, all of our attendees are currently in listen-only mode, meaning that you're not able to unmute yourself. However, if you experience any audio issues or AV things, go ahead and use the Q&A in Zoom just for those AV issues, and our tech support will be able to get back to you and hopefully straighten those things out. All right, next. My name is Hannah Dubelius, and I'm with the U.S. Department of Energy, and I have the wonderful pleasure of working with our commercial partners through the Better Buildings program. And today I'll be joined by Paul Torsellini, who is not only going to be a co-moderator, but he'll also be one of our speakers today to tell you one of his 5 things about heat pumps. So Paul's with the National Renewable Energy Laboratory, and in addition, he wears many hats. In addition to being leading the Design and Construction Allies program, he also supports technical assistance for the Better Climate Challenge. Next. For today, we are going to start off with just quick welcome and introductions, and then we are going to be going into these speaker presentations because we have 5 speakers today, each of whom are going to share with you one of the top 5 things you should know about heat pumps. However, those are going to be pretty quick because we are going to save plenty of time at the end for Q&A, so we can get to all of your questions. We know we have a lot of people on the line today, so we're hoping to get to a lot of those questions. Next. Speaking of your questions, we are using Slido.com, a tool today for a couple of polls and also Q&A. So right now, if you could go ahead and open up either a new browser in your internet or on your mobile device, you're going to go to Slido.com and enter the event code DOE. Our tech support has also gone ahead and dropped a link in the chat if that's easier for you, but I'm going to say these directions again because I would love it if right now you could go ahead and open that up. We'll be accepting Q&A throughout the entire presentation, and then we'll get to those at the end. You also have the opportunity in Slido to give a little thumbs up vote to other questions that you like, and that moves them up the queue so that we can be sure we're getting to the top questions from our audience. We will also be using Slido for a couple of polls, so we can go into that right now. Again, Slido.com is where you're going to use this, and we would like to just learn a little bit more about our audience today. Sounds like people are getting into that first question, which is which sector best describes your organization? We have a lot of contractors and consultants online, which is great. I know we're highlighting some of our design and construction allies today: local gov, nonprofits, industrial, state government, some commercial real estate. That's a sector I work with, so glad to see you on board here. Excellent. I appreciate all these people also using Slido again, since that's what we use to poll and also for Q&A. All right, we can go ahead and launch the next poll, please, which is, have you used heat pumps or HVAC systems? So what's the level of experience out there? Wow, okay, coming out strong with a lot of people that are new to heat pumps. Well, that's great, because I think we are going to cover a really wide range today of some of the basics up to some of the more advanced case studies looking into it. So someone's never and sometimes. All right. This is excellent and great for our panelists to know. Hopefully next time we do this poll up this webinar, we'll have a lot of most of the times. All right, excellent. We will move on to our third poll, which is, what is your primary motivation to use heat pumps for HVAC systems? We want to know what's driving you to maybe learn more about it. I know that a lot of people just told us that they have not used them yet.
Yeah, thank you so much, Hannah, for that great introduction. Thank you all for being here today. And I'm going to start by just getting us familiar with making sure everybody's on the same page with what a heat pump is, and starting from something that we probably all know: boilers and furnaces. So boilers and furnaces are energy conversion devices. On the source side, we're looking at a fuel source, and we're converting that fuel source to something that we want, in this case, useful heat for our building on the demand side. So one example, we combust natural gas in a hot water boiler to heat recirculating water. That is, these are really the most common ways that we provide heat into buildings. And the key there is that we are doing energy conversion. So we're taking a fuel source like natural gas, fuel oil, wood or biomass, or electric resistance to do that heating. Next slide, please. So in a heat pump, we're really talking about energy transfer. So on the source side, we have some thermal source. That could be outside air, that could be the ground source. I live in Missoula, Montana, and fun fact, we actually do a lot of heat pump heating using our river that runs right through town, or process heat like a data center or industrial process. Those are all thermal sources. And we're going to use a refrigeration cycle that's powered by electricity to transfer that thermal energy to our demand side and into useful heat. So in an air to water heat pump, we're actually pulling heat out of cold air, using that refrigeration cycle that's powered by electricity to create useful heat that we can push into our building. Next slide. So the reason that this is efficient, the reason that we want to do this a lot, is that refrigeration cycle is capable of moving more heat than it actually consumes in the electrical energy used to power the cycle. Many of you who have some experience with heat pumps know that the first cost of the equipment can be higher per unit of capacity installed. Sometimes there are other constraints, and we'll talk more about these later in the webinar, around electrical capacity or the amount of space you have to install the equipment. But generally, these are the key drivers, right? We're trading off efficiency with some amount of first cost. Next slide. And just for a point of comparison, right? When we do energy conversion, it's generally one way. We're converting fuel into heat, and you always lose a little bit. The best efficiency you can get is around 99%. But again, when we're transferring energy instead of converting it, we can actually get really great efficiencies, sometimes in the range of 2x to 10x the amount of electrical energy that we have to push into the system. The other really cool thing is that it's a reversible process. So our same heat pump piece of equipment can do heating in the winter, and it can also do cooling in the summer. And Paul's really going to hit on this in a great way later. Go to the next slide, please. So a really key thing to factor in when we're trying to do heat pump heating in our buildings is that the total size, the total capacity of our heating system has to meet the worst hour heat demand. So on the far right side of this chart, we see that worst hour heat demand at 8,400 kBTU per hour. What this chart is showing us is how much heat capacity you need during every single hour of the year. So on the left side, where the graph is flat at 0, right? That's the summer. We aren't doing a lot of heating in our building. Great. And during the shoulder seasons, fall and spring, we need a little bit of heat. And then for a very small chunk of hours, right, where that graph really ticks up on the far right side, that's where we need a lot of our heat. And so the big key point that I'm going to get at, the first key thing to know, is that you can do a lot of your heating with a heat pump that's not sized for that worst hour heat demand. Go to the next slide. So what we're talking about is a composite heat pump plant, where we use a perhaps relatively expensive but very energy efficient heat pump to do most of our heating most of the time. And then we use low cost and inefficient traditional equipment like boilers and furnaces to meet those occasional really high peak demand loads. And that gives us an optimized heat pump plant that has a much smaller carbon footprint, uses way less primary energy, and can be a very effective system for your building overall. So takeaway number one, go to the next slide. We can strive for an 80% solution, especially in colder climates. But there are actually some clever ways to do this in cooling dominated climates as well. We don't have to meet 100% of your peak load with heat pump equipment. That's all I got.
Great. Thank you so much, Skander. I really appreciate it of launching us and getting us started with some of those basics on our first of 5 things. Next up, we have Jess Farber, who has 3 decades of experience in engineering and sustainability in a range of markets. As Vice President for CMTA Consulting Engineers, he drives environmental transformation through zero energy projects and decarbonization initiatives. So thanks so much. You're up, Jess.
Great. Thanks, Anna. So the next part here we want to focus on is kind of dovetails well into what Skander was addressing. We have buildings that consume energy, and why? What are we trying to do and heat and cool with these buildings? So drastic energy reduction becomes key in order to manage costs. There's a lot of concerns about first costs with this system, et cetera. So we hope we can address some of those questions as we go through the next slides. Next slide, please. So again, we don't want to let the tail wag the dog. So the building is what needs the energy. So let's design the building properly so we can use the correct amount of energy to keep that as low as possible. Next slide. We're never going to get to zero. We never can get to absolute perfection, but we have to make sure as designers and installers and contractors, et cetera, that we're setting goals for projects so that we know what we're trying to obtain. So it's key when you start on any project that you understand what your goals and objectives are going to be. I like the cool mustache anyway. So next slide. So the key really comes down to is really you have to understand, where energy is being consumed in a building. And, when we study buildings and look at load profiles, et cetera, obviously the HVAC becomes the largest consumer of energy in a building, whether it's zero energy or whether it's not. That's just the biggest consumer in the typical commercial construction that we deal with. And that HVAC load can vary pretty greatly depending on the type of heat pump you choose. And we'll talk more about technologies here in a minute, but you've got air source, ground source, et cetera, that was discussed. So that can really have a big swing in terms of how low you can get those HVAC energy components down to. But really what I want to focus on here is the building envelope. So if we can go to the next slide, please. The building envelope obviously isn't an active energy consumer in a building, but it has a huge impact on energy consumption. And you have to be very mindful of that. Whether it's new construction or whether it's renovation, buildings can be made to be very efficient from a building envelope perspective. So again, every local code is different. I'm up in Boston, so we have a different set of codes than maybe you're going to have in the Midwest. So make sure you understand your building codes and what your minimum requirement is going to be. But if you're looking for the type of approach of drastic energy reduction, you're going to have to be well above code minimum compliance anyway. And you do see a lot of talk out there now, especially up here with passive house design too, and that can go a long way. But again, make sure you're looking at your building envelope and you optimize the amount of insulation you put in your building, and really focus on building infiltration. Infiltration is what we say is the killer when it comes to energy efficiency. You get a complaint a lot about heat pumps that is cold, like I'm always cold when my heat pump comes on. Well, a lot of it could become, if you look at the pictures here, the before and after of this shot, I mean, these are old leaky windows. You're going to be cold next to those windows. There's no way around it. So really looking at improving those barriers go a long way to improving energy efficiency and being comfortable in the building at the same time. Next slide. And so one step that is key that you really need to focus on is if you've gone to all this trouble, in the typical commercial world, when I think about mechanical, electrical systems, et cetera, we don't even question the need for commissioning of those types of systems. The building envelope is as critical as anything when it comes to that as well. So through a combination of blower door pressure testing and thermal scanning can go a long way to understand how your building is performing from a building envelope perspective. You can do this on your existing building and try to find out where the building could be leaking and try to make improvements. You can do it during construction as well to make sure that the building was constructed properly to meet your goals and targets and objectives. But again, it's a super key piece that we make sure that we understand how the building envelope is performing. Next slide. There's a lot of standards out there that kind of surround building envelope pressure testing. There are code requirements, and those are ever changing. Thankfully, we see those reducing. There's federal standards out there as well. But we find is that if you really want to have a building that performs well, that is low energy, that strikes a great balance between building envelope and the amount of HVAC system tonnage you have to install, we want to push that even lower. So we see a 0.15 CFM per square foot of building envelope to be a great target that's easily achievable in typical projects. We've seen this happen in new construction and in renovation projects. So again, make sure you understand what your goals and objectives are and try to push that envelope so that you can try to get to these goals. So these heat pump systems will work the way that you expect them to operate. Next slide. So this slide here, we wanted to address some of the cost concerns. Obviously, there is premiums we see out there in the market for ground source heat pumps. Again, check local listings to what your costs are. We see different variations depending on where you are, but there's never been more availability of financial incentives to invest in ground source heat pump technology, solar PV technology. Utility companies offer incentives for electrification with air source heat pumps. So again, check local listings and see what you can do, but there's a lot of money out there. 30 to 40% of your HVAC investment can come back to you if you choose these alternatives, which help really normalize those overall costs. Next slide. And up next to Paul.
All right. Thank you so much, Jess. Of course, reminding us something that's music to my ears about drastic energy reduction being very key. Something that I also know is near and dear to Paul's heart. So with that, I will turn it over to Paul Torslini from the National Renewable Energy Laboratory.
Thanks, Hannah. And I just looking through some of these great questions that are coming in. So keep those questions coming on slido.com. So, as I was thinking about this and kind of my one point, and of course I want lots of points, but my one point is really thinking about, the cooling mode. You probably already own something to do cooling. Even in a lot of the climates that we would consider the colder climates. One of the interesting things about this panel is the entire panel lives in climates that is heating dominated for the most part. And so, traditionally this cooling mode is that the outside is this high temperature and the building is the low temperature where you're trying to keep cooler. And go to the next slide. And really the heat pump is really just thinking about reversing that. In heating mode, using that heat to condition the building and using the outside to kind of collect that heat and putting energy in at the same time. Now, the benefit of this is that you already own this equipment in a lot of cases because you're making, something to make cooling, especially if you've got a larger plant with a chiller, or at least familiarity with the equipment that's there. One of the key barriers that we hear, and you can go to the next slide, is lack of electrical capacity. And, I think one of the things people think about is like, I've got this cooling system and I want to add something to make heat And so you think about it as a new piece of equipment to replace that boiler that you're trying to eliminate from the system. But really, you already have that electrical capacity in a lot of ways to hit most of the load, like Skander was talking about, with that air conditioning system. So think about taking that air conditioning system and turning it into a heating system. So you're still maintaining a refrigerant-based system. You should have a lot of familiarity with that. That's another barrier that we hear. And another barrier that we hear is that this equipment takes up more room compared to a boiler. But again, if you're thinking about it as a replacement for the cooling system or an add-on to the cooling system, then a lot of those issues kind of go away. There's also a lot of discussions that I hear about too much risk of the unknown, especially at the colder temperatures. And I think all of the speakers online will attest to having heat pumps that work in the climates that they're used to working in. But that's also where Skander's point about, think of it as, an 80-20 rule, right? And look at how much cooling capacity you have and how much heating you can do with that equivalent amount of cooling capacity, and use that as kind of the starting point. Next slide. So some of this message is leave the boiler alone at the moment and focus on the cooling system. Next slide. And so think about it as installing a heat pump that is at least as big as your air conditioning system. And if you run into, and kind of your electrical capacity may govern that. Many AC systems are already oversized. And so you have that piece, but also going what Jess says, that energy efficiency will help you deploy and help you extend that capacity of those systems, right? In fact, you have to be careful that your air conditioning system is not oversized, especially dealing with humidity. Reset the night setback temperature based on the outside temperature. As it gets colder out, actually use less setback. Many buildings peak their heating system during that warm up. So you can extend that time or maybe not set back as much, especially when you know it's going to be very cold, to take advantage of, downsizing that heat pump system a little bit, and just keeping it more consistently running. And then another option is rework the plumbing on the chiller to also provide heating, especially in the non-winter months. And one of the strategies to think about here is using the heat that's coming off of your chiller to provide your reheat if you have a hydronic-based reheat system. And again, going back to tips 1 and 2, energy efficiency, and in most US climates, you can achieve at least 80% of the heating load with this kind of strategy. Next slide. So one of the questions that also comes up quite a bit is around the refrigerants. And again, most of you probably already have refrigerants on site because of air conditioning systems. And we're just kind of double dipping that same refrigerant also used as part of the heating system, as opposed to, again, creating an entire new system. But there's a lot of discussion about lower GWP alternatives to what's out there today. Things like 410A are especially popular. But we're starting to see a lot more equipment with lower greenhouse warming potential, such as R32. Some systems, especially for domestic hot water, are looking at carbon dioxide. And propane is also starting to become available, especially in some of the smaller applications. Next slide. And so I'm going to stick on number 3 for the moment, that focus on your cooling system and not necessarily the heating system in order to solve your heating needs. And I'll turn it back to you, Hannah.
Great. Thank you so much, Paul. And as Paul also reminded, we are collecting Q&A through Slido.com. You're using the link or the Slido.com and the event code DOE. You also, again, can upvote other people's questions. I know there's a lot of activity going on there, so I appreciate that. And with that, we'll move forward with Drake Wallers, who leads a team of engineers providing services for Lepardo companies that expand beyond the traditional construction procurement model. So thanks so much. And Drake, take it away.
Thank you, Hannah. So I guess as we heard so far, we've heard about the technology and basically how it works. I'm here to talk about applying that technology and how the equipment operates. And heat pumps have come a long way. They've been around for a while, but they've come a long way. And there's a lot of new technology, especially in the past few years. Now, especially that decarbonization is accelerating. There's a lot of new technologies out there. So my big point here is finding the right heat pump for the job, for the best performance, because there's a lot of, I guess, pitfalls with heat pumps that happened in the past. And so there's some, kind of preconceived notions about how they operate, but finding the right heat pump for the job, you'll get the best performance. Next slide, please. So the good, I guess, is heat pumps have been around for a while. The technology is proven, the principles have been proven. The bad, they've been around for a while, and there are a lot of old technologies out there, and people have ideas about how they operate. I'm sure you've seen a lot of these old residential style units out there. A lot of them, believe it or not, are heat pumps, but there are limitations to them, and which leads to the ugly. And I guarantee you, if you're going to Google image heat pumps, you could find one of these images in the far right, where something's frozen over, they're not heating properly, and you have performance issues. And really, that's just based on poor implementation or not choosing the right equipment for the space, which leads to poor performance. And poor performance leads to these negative perceptions. And we're here, and I notice, I think most of us here on the call are consultants, or the majority at least, is to help our building owners and clients kind of overcome that and realize that there are several better technologies out there, and with the right tools, we can apply the right heat pump and get the job done. Next slide, please. So this is just a really broad overview of all the equipment out there. Over to the left, I'm kind of going from where heat pumps began and kind of where the initial perception is, where heat pumps are mostly, and now that's a picture of like a small hotel unit. You may have seen those. Believe it or not, a lot of those are heat pumps. Heat pumps are typically been just small modular units, typically small in size, limiting capability, capacity, and limited in how you can apply them. Well, since then, and even like I said, the past few years, the equipment has evolved rapidly, and not only that, but our knowledge has evolved and how we apply them. We've learned a lot. We've, learned from our mistakes, I guess, and how these are applied. And over to the right, there's just some examples of, we have over here called a variable refrigerant flow system, which is basically a heat pump that can serve multiple spaces that's connected to a single system. There are larger rooftop units that have higher capacities. Typically, you think of heat pumps as residential units that are 5-6 tons, small capacity. Now they're about 5 to 6 times that capacity, and they can serve much larger spaces. Not only that, they could serve the air side, but they can also be hydronic systems. They can replace your hot water boilers. So there's heat pump chillers, there's heat pump boilers that'll serve as hot water systems as well. So there's a lot more technology out there, and it's just becoming familiar with all the different manufacturers out there and understanding all the technology. The next slide, please. So this comes to understanding the right heat pump for the job. There are still residential units out there. They've evolved a lot. They have come a long way in terms of their ability to heat during the wintertime. I think all of our panelists are actually from northern climates here, as I think we talked about that on the call. So we know that this technology can work, and without the use of gas heat in many cases. So there's different systems, for offices and classrooms. There's those variable refrigerant systems that serve multiple spaces. And as I mentioned, those larger systems can now serve those large spaces, those gymnasiums and auditoriums. There are larger rooftop units that are completely heat pumped that can serve those type of spaces. Next slide, please. And just some additional considerations. I know Paul mentioned, talking about the electrical. Yeah, it's good to consider that, but it may not be a barrier. like Paul said, it's just, maybe you're just designing around your cooling system and you're leaving that heating system in place. Think about that 80%, 20% rule that we were talking about. You might be able to take care of 80% of your heating needs and leaving that remaining 20% if you can't get rid of it, if it's too cost prohibitive, or if there's, extreme weather conditions. Separating your outside air is another way to kind of separate that, to that 80-20 rule. Maybe you're separating those extreme conditions from most of your heating needs. And then the last two parts here, I have, using building automation, setting back, and then also your utility tariffs, making sure that you can switch to a certain utility tariff. Many utilities offer certain tariffs for space heating that are more cost beneficial. So just be aware of that as you're switching to a heat pump. Next slide, please. And that's all I have. Thank you, Hannah.
Great. Thank you so much, Drake. And again, Drake's reminding us that you need the right heat pump for the job. So thank you so much. Our last speaker today, last but not least, will be providing our fifth thing, rather. Ben Myers is the Senior Vice President, Sustainability at BXP, the largest publicly traded developer, owner, and manager of premier workplaces in the United States, and a Better Climate Challenge partner. I would be remiss if I didn't mention. So thanks so much. And Ben, please finish out our list for us here.
Thanks, Hannah. It's a pleasure to be here running anchor on this heat pump expert relay. I am going to talk about why I love heat pumps. And I love heat pumps because they're essential for driving BXP's emission scopes 1 and 2 to 0. Very rarely do we have a silver bullet in decarbonization. There are many silver bullets, and heat pumps are absolutely one of them. So for BXP, about 40,000 metric tons of carbon dioxide equivalent are our scope 1 and scope 2 emissions, and heat pumps are enabling BXP to transition away from systems of thermal heating that rely on fossil fuels. So about 6% of our total emissions footprint here on the right is natural gas combustion, and that's primarily for heating, space heating, and we're serving our tenants with space heating. So very much commercial real estate owners like BXP are in the business of providing heating and cooling to customers, and we want to shift our heating generation away from fossil fuels. Next slide, please. So we have a strong commitment to decarbonization and are going to achieve carbon neutral operations in 2025. And the primary methods we're doing this are energy efficiency, and we've heard today the importance of energy efficiency. Energy efficiency is the most important part of decarbonization, and we've cut our energy use intensity almost 40%. And that's down from about an EUI, site EUI of 95 in 2008, down to 58 in 2022. Secondarily, we're buying renewable power. And the third piece is electrification. And a lot of the electrification work we're doing at the moment is supported by efficiency first and heat pumps second. Next slide, please. So when you look at this chart of how we get to carbon neutral operations from a 2008 baseline, energy efficiency is about a third of our total emissions reduction from 2008 to 2025. Secondarily, grid and district steam improvement, the emissions factors are getting better. That's another approximately third of our goal progress, followed by 27% voluntary green power procurement, and then 8% as carbon offsets. And the offsets are addressing what remains in terms of on-site gas-fired systems. These are newer gas-fired boiler plants that were the best practice not long ago. These are high efficiency condenser boilers. However, technology advancements, which we see with heat pumps, is causing best practices to shift. And they're shifting towards high COP solutions that are fully electric. There are a number of reasons to do this. Decarbonization is one of them. We say decarb. I really think it's about quality of life. And I think it's about better air quality. I think it's about mitigating climate change. We say decarbonization, but I think we're all after those outcomes as well. Next slide, please. So this is one of a few examples I want to share of where BXP is implementing heat pump solutions. So we've just opened 140 Kendrick Street in Needham, Massachusetts. It's a 106,000 square foot commercial office building. It's a 20-year-old office building that we've repositioned as fully net zero, cutting energy use intensity 40%, installing 1.4 megawatts of on-site solar and energy storage, producing 1.4 million kilowatt hours annually of renewable generation. That'll be more generation than we consume in the building on an annual basis. We're saving a lot of embodied carbon by reusing existing building. The most sustainable building is the building you don't build. We're recovering 90%, it's actually greater than 90% of heat in the building through a super block heat recovery system. We talk about efficiency. Heat recovery is a very important part of efficiency. If you're recovering heat, you're not having to generate it with heat pumps, which reduce your peak demand. And then 38% reduction in indoor water use. The mantra for this project is build tight, ventilate right, energize with sunlight. And the heat pump solution is part of a VRF system for the 2 air handling units shown on the roof. And so we were able to cut the gas line completely, shift to air source VRF with advanced recovery, going fully electric at 140 Kendrick Street in Needham. Next slide, please. At 601 Lexington Avenue, we're using water source heat pumps. So last project was air source heat pumps. These are water source heat pumps to recover heat from the central condenser loop. And through in 2025, it will be net zero carbon at this building. It's a 1.7 million square foot office building in Manhattan. And this building will cut its steam use 30% using heat pumps. It had already cut its steam use 60% by shifting from steam chillers to modern electric drive chillers. Next slide, please. And finally, a few other projects. Platform 16 in San Jose, California, 1.1 million square foot, 6-story office building, an entirely electrified heating system. This project's under development, all air source heat pump design. 121 Broadway in Cambridge, Massachusetts. Now we're getting into colder climate zones. This is a residential ground up development, 420,000 square feet, 38 stories. This is an air source heat pump project with backup electric resistance boilers. This building will be fully electric. It's our first ground up residential 100% electric building in a cold climate zone. And then probably the most exciting project we're developing now, 290 Binney Street, a life science building in Cambridge, Massachusetts. It's 556,000 square feet, 16 stories. And this building has an air source heat pump system with heat recovery chillers and water source chillers. And this project with advanced heat recovery will be primarily electric. It'll have a backup thermal coupling with the district system, but we expect, based on our modeling, that the building will be able to run year-round using heat pumps only, which is very challenging for a life science asset given the air change requirements. And so this is really cutting edge for the company and cutting edge for the industry. And I'm tremendously excited about 290 Binney. Next slide, please. In closing, heat pumps are essential to achieving net zero targets, certainly for BXP and absolutely for the rest of the built environment.
Excellent. Thank you so much, Ben. I really appreciate you rounding that out with some of the case studies as well. And I know that it's been some exciting projects you're working on. I'm going to have us just linger on this slide a little bit so people can absorb our 5 things all together, and maybe also continue to drop some questions into Q&A. Before we get to Q&A, although I'm pleased we have at least 20 minutes for this, we actually do have one more poll question for you all now that you've absorbed some of this information. So if you're not already, you can go to slido.com and put in the event code DOE. So we've got one more poll question for our audience here, which is, what are the challenges of implementing heat pumps? What's your biggest fear? So I think we've had some time on this call to that they will fail customers. Of course, failure, perhaps the biggest fear here for our buildings. Yeah, performance, reliability, the electrical capacity. And I think some of our 5 things did start to address this, the importance of building envelope and reducing your electric load of the building to begin with. Cost and payback. I know I'm seeing a lot of that in the Q&A portion of Slido. So I think that we'll be able to maybe address some of those things in our Q&A. Yeah, that remaining 20%. I know that's been a hot topic in Q&A that Skander brought up. Find someone who will install it in my home. That's actually something I'm thinking about for my own home right now too. Yeah, choices on equipment. All right, I'm feeling a lot of heat pump anxiety here. So thank you all so much. This is really helpful for our panelists and also for DOE in general. And I am ready to quell some of this heat pump anxiety. So we're going to switch back over, I think, to the Q&A. It's not too late to still add other questions or to hit that thumbs up to upvote questions to the top of our list. And I see that our panelists have, these just keep coming, wow. We're going to solve some of these problems today. So I see that our panelists have all joined us back on video, so thank you so much. And yes, great, and we switched over to our Q&A here. So, and Paul and I are going to tag team this just a little bit, but we are going to get into our first question. A reminder to our panelists that some of these are addressed to someone individually. So we'll start with that person, but anyone's welcome to respond, but also for time purposes, would be great if not everyone responded on every question so we can get to more of these audience questions. So Jess, you are first in the hot seat here because our first question is retrofitting existing older buildings to upgrade building envelope is very expensive. Any thoughts or ideas about overcoming that challenge?
Of course, I have thoughts about that. So the slide that I presented in the graphic on that was a retrofit renovate as new school facility in Connecticut. The building was undergoing a total renewal. The roof needed to be replaced, the windows needed to be replaced, the walls needed improvement. So that was figured into the budgets as that project was conceptualized. And on top of that, once we know we're doing that, we can then start to right size the HVAC system and not oversize those components to help mitigate some of those costs. But just to go into a building and put a new roof on it, if you're doing it, think about maybe how you could go better than code minimum. Like I said before, what can you do is take it to the next step to help make some of these costs you have to be spending anyway, because you need to maintain your building and do it. Just take it to the next level when you're doing that, and just don't go with a 1-for-1 swap out. That's not going to get you anywhere. So yes, they can be expensive, but when you fold it into the entire project, that project bid under the owner's budget when we did it 2 years ago. So it can be done if it's done with the whole building in mind.
Yeah, thanks, Jess. I think it's important to really think about, you spend money on buildings every day. And when you spend money, are you spending it in a way that's helping you achieve your decarbonization goals at the same time? And so there's, good opportunities there, when you are doing rehab, as what Jess said. Ben, could you also address this, and in particular, how you looked at kind of the walls and the roof? And I know you did a lot of cost analysis and made it work out for you as well as your tenants.
Right. So the particular case study, 140 Kendrick Street, to Jess's point, there was a life cycle event for that asset where it was being relet to a new tenant. And so we were out in the market with the building, positioning it, and we had a few options where we were looking at a green retrofit, a deep green retrofit, and a net zero retrofit. And the net zero retrofit entailed full envelope insulation going R30 at the walls, R40 at the roof. It included the renewable energy. It included the advanced heat recovery. And part of our business case formation for that project was wanting to attract a client that wanted to share in our net zero journey and participate. And so we were able to work with Wellington Management on that project, and they agreed to share the premium costs associated with some of the installation upgrades and some of the other heat recovery work and full electrification work. So I do think for some of these investments, the business case formation is going to depend on client demand. It's also going to depend on the incentives that we were talking about earlier, whether they're offered through a local distribution company or a program manager affiliated with the utility, or through the Inflation Reduction Act in the event, certainly with ground source heat pumps, where we're looking at those for a few sites now. But I do think that the business case is largely dependent on those factors: client demand, for our case in commercial real estate, and also available incentives combined with energy modeling and a look at operating costs. One decision we made, Paul, and you may be referencing this decision, was, do we have to upgrade the windows from double pane 20-year-old windows to triple pane? And the triple pane change was not only costly, but also came at a large carbon penalty. So we did the embodied carbon analysis of replacing the existing windows versus leaving them in place, and the energy penalty for retaining the film double pane glazing windows, which had a relatively good U value and solar heat gain coefficient to begin with. And it just it didn't make sense to go triple pane. So I think you want to look at what really matters. There's no prescriptive solution. You want to look at every asset in its context to spec the right systems, and also scope out the right improvements to the envelope to get the energy efficiency you need to achieve your outcomes you're looking for, which in our case was net zero operation.
Great, thank you so much. I appreciate the responses on that. Because this was such a hot topic, I also want to open up if anyone else would like to weigh in before we move to the next question here. All right, great. Then our next most popular question here was, can someone speak to common maintenance or repair issues with heat pumps in relation to other HVAC options? And I know this definitely draws back to some of the fears we heard about maintenance and potentially failures, and then also some of the barriers we heard at the beginning polls. So does anyone want to, if you want to jump in on that, panelists, just pop on.
I'll speak to this a little bit.
Great.
If you're maintaining your cooling system on an existing unit, you're able to maintain that heating system. So let's say, if it's a rooftop unit and now it's a heat pump, well, if you're maintaining those condenser coils through routine service and you're keeping those clean, you're maintaining your heating system as well. So just think about that. There really isn't much more maintenance that has to be done. If you're already maintaining that equipment already, and for your cooling, you're going to be maintaining that heating system as well for that optimal performance.
Thanks, Trey. All right. Skander, looks like the next one is addressed to you. So with the increase in extreme weather events, what sort of consideration should be going into design of heat pumps to ensure reliability for critical process load?
Yeah, great topic. So I think there's a nuance here, right? If we're talking about critical process loads, either in manufacturing or healthcare, understanding if we're talking about the reliability of meeting those process loads, or if we're just talking about the reliability of our heat pump system. What we are often designing on the heat pump system side is modular heat pumps that I think Drake mentioned specifically, available from many manufacturers in many sizes and configurations and applications. And that the power of those modular systems particularly is that you're not buying a single large piece of equipment, you're actually buying a series of smaller pieces of equipment that all work together in concert and can be serviced separately. And so say your building needs 5 modules. If you have a very specific concern about reliability of that heat pump array, that's that group of modules, you might just want to buy a 6th module, because then you've always got 5 modules that are maybe available to work, and 1 module that could be down for maintenance. So that's a way to address the reliability. I think it does get more challenging, right? As your loads get smaller and as the capacity of your system gets smaller, you need fewer and fewer pieces of equipment. And so the cost of that reliability gets higher. One small point to tack on to the previous question around maintenance and reliability, when we're talking about energy conversion devices, those boilers and furnaces, because we're usually just combusting a fuel, that's a relatively simple piece of equipment. Dirty secret in HVAC, there are an awful lot of pieces of HVAC equipment that just sit up on rooftops and rot, and they don't get maintained whatsoever. A heat pump is, it's got more parts and pieces. You do have to do maintenance on it. And it will serve for a very long time if it's properly maintained. So when we're talking about, if we're talking about a heating only comparison, and you're not doing any maintenance for your very simple energy conversion device, yes, your maintenance schedule is going to look a little bit different for your heat pump environment. To speak to the last piece of this question, if we're talking about a critical process load, industrial or healthcare or something else, that may be a system where you need a whole secondary system. If we're talking about data center cooling, right, there's often we'll have some kind of compressorized cooling system. And then we also might have a backup evap cooler or air side economizer system. It depends on how critical that process load is. Very nuanced question, very can be a challenging application. So suffice to say, across all of these questions and all of these topics, which are all really important and valid, right? If we want to do something better and different than we've done it in the past, we have to apply more technology and more brain power. I will say overall, the questions of engineering decarbonized systems are a little bit trickier. We are across the industry developing a playbook. There is a ton of knowledge. One of the great joys of getting on this panel was that we got 5 engineers in a room and all of us had really valuable things to say. We didn't really argue with each other at all. We're all really smart and have really great experience that we're bringing to the table on this. And we're figuring it out. So I think all of these things do require a little bit more brain power and technology.
Thanks, Gator. I appreciate you addressing multiple aspects that this question could connotate as well. With that, are there anyone else who'd like to weigh in on this? Since I know there's the reliability piece, the kind of critical infrastructure piece here that he spoke on.
I guess I would just say, Hannah, on this, that, don't look, sometimes I think it's in our character to look for the worst possible case and decide if it's going to work for that or not. There are so many applications that work really well for heat pumps in all of our buildings. And at least as a starting point, start with the ones that you can get good wins with, that you've got the electrical capacity of. Even the building Ben referred to had electric resistance reheat as part of it, which they maintain, and they really just looked at replacing the gas on the kind of the central air handler. Look for places that you can make equipment work. And there are going to be some that are going to be much harder, and as Skander said, need more brain power. They can be solved, but there's also a lot that are kind of the low-hanging fruit of deploying heat pumps.
Yeah, great. Thanks, Paul. All right. We're going to move on to our next question then, which is in a cold climate building with PV that takes care of summer cooling, what advantage is there to using a cold climate heat pump when much of winter would be well under 20 degrees Fahrenheit? Seems like you'd only use the heat pump on the shoulders and not see much advantage. Anyone would like to address that?
I'll take a stab at it. So I'm not sure how the PV takes care of summer cooling. I mean, you still have a cooling system, but the PV may be helping energize that system. But these cold temperature heat pumps, we expect to operate below 20 degrees Fahrenheit, well below 20 degrees Fahrenheit. And we will be operating the heat pumps year round. One of the ways we mitigate the lower coefficient of performance, meaning the less energy efficient operation at colder temperatures, is by recovering more of the heat in the building and keeping more of the heat in the building with a better envelope. And I think that's going to be a recurring theme of today's conversation. Is usually when you're looking at a heat pump system, you aren't breaking it out independently. You're coupling the installation of that heat pump system with envelope improvements and heat recovery improvements. And that's what makes the whole thing work. But I think it's incorrect to assume that heat pumps won't operate under 20 degrees Fahrenheit. We think they'll operate well under 20 degrees Fahrenheit into negative degree territory without issues, based on what we've seen in terms of performance recently. And I think this is something that owners like VXP need to prove out with more data to dispel these concerns. Saw a report out of Maine. Maine homeowners are very happy with their heat pump performance in cold weather, sub-zero temperatures. We need to get that word out. We need to do a better job getting that word out on heat pumps.
If I can add to that, Ben, I think we have a particular client where we're doing a similar type of air source heat pump, more of what I consider a 4-pipe traditional VAV system applied with air source chiller heater unit. there is a concern, of those low temps. And so I think each case has to be thought about uniquely with the owner and understanding what their concerns are. And then as an engineer, how do you then address their concerns with redundancy and resiliency? So for that particular client, I think it was mentioned earlier, we added an extra module to the air source so that I have that redundancy built in. Those things will operate, down to below 0. Your COPs start to drop below 2, which is still better than 1. So you're still getting decent efficiency, not as good as it will be obviously in the shoulder seasons. But the other thing I would say is that there are still alternatives for those extreme days where you might put in an electric boiler to help cut that 1% or less than 1% of the hours you're talking about. So I think that the moral of the story here is don't let those extreme days drive the decisions you're trying to make. Look at what your total profile will be, then try to make the decision best suited to your particular project.
Thanks, Jess. And I think that's a theme I've certainly heard from a couple of you about when you're planning for that. Unfortunately, it's actually time to move to our conclusion here. So I would just like to say again, thank you so much to our 5 panelists here. We really appreciate it. We know this was a very hot topic, pun intended, for our audience. So we really appreciate you coming out and sharing these things. For our audience, these slides, as well as the transcript and the recording, will be available in the Better Building Solutions Center. And you'll also get an email when that's available in case you want to watch it again because you loved it so much or share with a colleague. I would like to also invite everybody to join the last couple of webinars we have in our summer series. We've got 3 left before the end of our summer series, and then we'll be launching our fall and spring series after that. In particular, you can join us on August 15th for our next webinar titled Here Comes the Sun, Innovative Community Solar Systems. You can join that webinar to learn more about the benefits of community solar, get resources from DOE's Solar Energy Technology Office, and find out how Better Buildings partners are planning and implementing best practices. So with that, thank you so much, panelists. I know we didn't get to a lot of our questions, so we do throw your emails out here for the audience masses to potentially follow up with you. And for our audience, you're also welcome to follow Better Buildings on a variety of social media channels. You can stay up to date for all the webinars that we have. Thank you all so much. Have a great rest of your day and good luck with all of your heat pumps. I can't wait to hear how all these projects go.